Okay, so here's my dilemma. Here's my I don't like it part of this lesson. I'm teaching you this idea of special cases today, and they are not very common. They don't happen all the time. In fact, most of the time you're going to get an answer, just like we did yesterday and the day before and the day before and the day before. Every once in a while, something special will happen. So we follow the same steps every time. Step 1, are there parentheses? That's our question. You ask yourself always, question number 1, are there parentheses? And if the answer is yes, what do you do? Distribute. If the answer is yes, there are parentheses, we're going to distribute. If the answer is no, we skip it, right? Yep. We go to number 2. We skip step 1. Go to number 2. After we do, are there parentheses? We ask ourselves, are there parentheses? And we either say yes or no. What's the second thing we ask ourselves? Are there like terms? And remember, let's just put a little disclaimer down here. It's the same variable, and they're on the same side, right? If they're 2 x's or 3 y's, if there's a 5 and a 7, if they're the same variable on the same side, they have to be on the left side together or on the right side together. It can't be on opposite sides. They have to be on the same side. And if the answer is yes, we're going to combine, right? Yes. Which is add or subtract together, right? We're going to combine them together. We're going to make them into one. If the answer is no, we skip. We're going to skip to number 3. I guess I'll put this skip to number 2. All right, so these 2 questions that we've asked ourselves are not new. Is that correct? We've asked ourselves, are there parentheses? Every time. Are there like terms? We've asked every time. So then 3, when we got to variables on both sides, we then asked ourselves, is there a smaller variable? And remember, these are on opposite sides, correct? Now, the new part today. Sometimes you'd say, no, there is not a smaller variable. Sometimes you say, yes, there is a smaller variable. The new part today you can also add in, are the variables the same? Because if there's a smaller variable, or the variables are the same, yes, there is a smaller variable, or yes, the variables are the same, we move with inverse add or subtract, right? If the answer is yes, there is a smaller variable, or yes, the variables are exactly the same, make sure you're adding in that are the variables the same. That's the new part today. If the answer is no, you're going to skip to number 4. And then step 4, is there a constant? And let's add in this, it's the lonely number on the variable side. We got a little confused yesterday on which number was the constant. Sometimes that lonely number is the answer. It's not a constant. So the constant is the lonely number on the variable side. And if the answer is yes, there is a constant, we do the inverse, plus or minus. If the answer is no, we skip to number 5. And question number 5 that we ask is there a coefficient? And if there's a coefficient, remember this touches the variable. If the answer is yes, we multiply or divide. If the answer is no, we need to check it. All right, so we're going to talk through some practice. What is the new addition to our notes? If the variables are the same. And you guys, this part, I'm going to highlight it because this is going to be the game changer. All right, going to this practice problem. Question number 1. Are there parentheses? No, there are not parentheses. Number 2, are there like terms? Yes. Are there like terms on the left side? No. So I'm going to put 2 plus 6a. Equals, the like terms are on the right side, is that correct? Let's see. -1 plus 3. What's -1 plus 3? And hold on while I get this back. So you have -1 plus 3 All right, and then we have 1a plus 5a. What's 1a plus 5a? 6a, and it's positive, so I'm going to put plus 6a. So, no, there were not parentheses, so I did not need to distribute. Yes, there were like terms, so I combined them. Step 3, is there a smaller variable?
No.
But the new question, are the variables the same?
Yes.
Yes, the variables are the same.
That makes it 0.
So I'm going to move with inverse operations. Ready?
Oh my God.
So I'm going to pick one. It doesn't matter which one because they're the same. And I'm going to subtract 6a from both sides. And I'm left with 2 equals 2. And I'm going to stop. Because here's the new part. Here's what happened. I got rid of my variable. And the whole point of this lesson, these problems, is to figure out what your variable is. And what happened to my variable?
It disappeared.
It disappeared. Ladies and gentlemen, my question now is this true or false?
True.
I mean, it's true.
It's true. So my answer is all real numbers. This means any number is what a equals in this problem. A equals 5. A also equals -7. A equals 3.2. And A equals -3/4. A, the variable in this problem, is every single possible number. Any number would work for this problem because my variable disappeared, because my variables were the same, and when I moved one of the variables to the other side, my variables disappeared, and I was left with a true statement. 2 does equal 2, that's true. So every single number you know works. I'll prove it to you. 2 plus 6 times 3. So over here I'm going to use 3. -1 plus, and instead of a, I'll put 3 plus 3 plus 5 times 3. Right? And they both equal 20. 3 is a true answer. Now I'll try -8. 2 plus 6 times -8. -1 plus -8 plus 3 plus 5 times -8.
Oh, snap.
Every number works because my variables were the same, and when I moved one variable to the other side, they canceled out, and I was left with a true statement. So the answer is all real numbers. Yes, ma'am?
We say A equals all real numbers?
You say all real numbers. So let's try another one. Now, here's the problem. I teach this, and then all of a sudden you're like, oh man, no, all real numbers, all real numbers, all real no. It does not happen that often. Let's do the next one. Question. Are there parentheses? Do we need to distribute? So, do I need to distribute on the left side?
No.
-21 plus 6a. Braden, please take your stuff into the hallway. On the right side, I need to distribute. 2 times 3a is 6a. And 2 times -7, take your stuff please, is -14. Question 1, did I need to distribute? The answer was yes, because there were parentheses. Question 2, are there like terms? No. If I look at the left side, nothing goes together. The right side, nothing goes together. Question 3, is there a smaller variable?
Yes.
There's
No.
not a smaller variable. Are they the same?
Yeah, that's what I meant to say.
So here's I answered yes and no. So let's see what happens.
Oh, wait, was that the bottom one?
Well, no, but that's just walking us through. So I need to move one of them, because if they're the same, I still move. So I'm going to move -6a, -6a. And I'm left with -21 equals -14. Last time we did this problem, it was true. This time, is it true? No, it's false. So instead of every single number working, guess what? No number works. This is called a no solution. This is called a no solution. There is no number that would ever work. Now again, all real numbers is when it's true. No solution is when it's false. It does not happen very often. Right now in our notes, it's happening because we're learning about it. But very rarely will you ever have no solution, all real numbers, no solution, all real numbers, 5 as your answers. Most of the time you get a number answer. Let's try the next one. Draw your line down your equal sign. Question 1, do I need to distribute?
Yeah.
Yes. And in fact, I distribute on both sides. 7 times 7 is 49. 7 times positive 4p is positive 28p.
Oh yeah.
Then I go to my right side to distribute because I have to distribute both sides because there are 2 sets of parentheses. I have -7 times 5, which is -35. And I have -7 times -4p, which is positive 28p. I distribute in this problem because there are parentheses. Are there like terms in this problem now?
No.
Nope. Is there a smaller variable? No. Are the variables the same?
Yeah.
Yes. Because this is where my problem kind of falls apart.
It crumbles like a cookie.
If you look at this problem, my variables are the same. So I'm going to move one of them. Doesn't matter which one. -28p on both sides because they're both the same. And what am I left with? I'm left with 49 equals -35. Is that true or false? So what's my answer? Why is it no solution? Yeah, because I can't solve it. It's false, right? If it was true, I could use any number. But this does not work. It's false. It's no solution. Because 49 does not equal negative 35. Try the next one. I'll put my answers up. You try the next one.
Did I get it right? Did I get it right? Uh-huh.
I need to distribute. The answer to question 1 is yes. 1 plus 2x equals 5x minus 20 minus 6x. Yes, there are like terms. 1 plus 2x equals negative 1x minus 20. Is there a smaller variable? Yes. So I add 1x to both sides. Is there a constant? Yes, the constant is 1 because remember the constant is the lonely number on the variable side. Minus 1, minus 1. 3x equals negative 21. Is there a coefficient? Yes. Divided by 3, divided by 3. X equals negative 7. Ladies and gentlemen, when you get a number answer, please check. It makes me so sad to grade a test or a quiz and students get problems like this wrong because they would have known that they needed to do it again to fix the problem if they would have checked it. 1 plus 2x, so I'm going to do 2 times negative 7. 1 plus 2, and then instead of x I put negative 7. Then I'm going to go over here and I'm going to do 5 parentheses, and instead of x I'm going to put negative 7 minus 4, close parentheses, minus 6 times negative 7. And I get the same answer, so I know it's right.